Okay, let's keep talking about subsetting. This time we're going to look at subsetting lists. Okay, so lists and atomic vectors are similar, but they are different because they are similar in that they're both one-dimensional structures. But with lists can contain other things, and so we need to be able to distinguish between the contents of the list and elements of the list. And so we have single square brackets and we have double square brackets. Okay, when you use a single square bracket on a list, what you get back is always going to be a list. When you use a double square bracket, what you will get back is you will get the component that is being stored inside the list. Double square brackets can only handle one value, whereas single square brackets, you can give it multiple values. Okay, so these the subsetting operations, double square bracket and the $sign, dollar sign is also similar to double square bracket, are similar to the single square brackets, okay, except the double square bracket can only return a single object and it pulls pieces out of the list. Okay, dollar sign for subsetting a list is basically shorthand for the double square bracket, but you use it with names. Okay, one way to help us think about lists is you think of a list as a train. Okay, a train carrying multiple train cars, and each train car contains objects. So X double square bracket 5 is the object inside train car number 5, whereas X single square bracket 4 through 6 is basically a train consisting of train cars 4, 5, and 6. So here we are going to create X. X is a list of 3 train cars. It is a list of length 3. The first train car contains the vector 1, 2, 3. The second train car contains the character A, and the third train car contains the vector 4, 5, 6. If you do X single square bracket 1, that returns the train car with the vector 1, 2, 3 inside of it. If you do X double square bracket 1, you get the object inside that train car, which is the vector containing 1, 2, 3. All right? These illustrations come from the Advanced Art textbook by Hadley Wickham. So again, think of a list as a train with cars. Single square bracket will return the train with that particular car. Double square bracket returns the object inside the train car. All right, so here again, the train is X, 3 cars. X single square bracket 1 through 2 gives us back the first 2 cars. X single square bracket negative 2 gives me back the train without the second car. X single square bracket C 1, 1 gives me a train with the first car kind of duplicated. And X single square bracket 0 gives me back basically a train with no cars. The double square bracket can only return a single object. Okay, and so with the double square bracket, you have to put in basically just a single integer or single string. So here is a list with 3 cars in it, and we're giving the cars the name A, the second car gets the name B, the third car gets the name C. And so here I can say, what is X? X is basically a list. First car is A with the vector 1, 2, 3. Second car is B with the character A. Third car is C, named C with 4, 5, 6. X double square bracket 1 gives me the contents of that first train car, the vector 1, 2, 3. X double square bracket with the character A gives me back the same exact thing, the vector with 1, 2, 3 in it. If I use single square brackets, I can give it a vector, okay, with A, B, and B, okay, and that will give me back a train car consisting of train car A, train car B, and again, train car B. All right, if I try to do something similar here, and I do x double square bracket using with a vector a comma b, it is not able to do that. It is not able to extract out the element from car A and the element from car B and combine them or something like that. You end up getting an error. You get error subscript out of bounds. Okay, now technically what is going on is that when you put multiple elements inside a double square bracket, it performs what's called recursive subsetting. It's a little bit confusing, and so I don't recommend using recursive subsetting. When you do x double square bracket a comma b inside a vector like this is actually equivalent to doing x double square bracket a and then double square bracket b. And this will work if x has basically a train car named A, and within A is another list where there's another train car A. So you can imagine a train with cars, and within that first train car there's like a miniature train, another list inside of it, and inside that there's also another train car with A and B. And so if this is your kind of your structure, where x is a list where you have two elements, A and B, and this element A itself is a list, then this will actually work. You can do x double square bracket A, then double square bracket B, and that will go into the A first, and then once you're inside A, it will find the B, and it will pull out this character B. And then you could do x double square bracket A comma B. So this thing would actually work if you have this kind of structure. Again, it's a little bit odd, a little bit confusing, and I would say this is not recommended, but it is something that does exist. All right, so let's just kind of really make sure we understand list subsetting here. So here's another example. Here I have a list called D. List D consists of 3 train cars, 3 elements. It's a list of length 3, and the names are A, B, and C. A is a numeric vector, or type double, with the values 1, 2, 3. B, it contains a vector true, true, false, and C contains a vector with just the character A. Anytime you want to see kind of how a list looks, you can always ask structure of that list, structure D, and that's what we get. Okay, so let's look at what we get. Using D single square bracket 1, that pulls out the train car A, the first train car. And so we get train car A with inside of that train car A is the vector 1, 2, 3. When you ask what is the type of on this, it's going to be a list. This is a list of length 1 containing a vector there. D double square bracket 1 does only returns the contents of that train car, the vector itself. The vector itself. It doesn't return a list, it returns the contents of that train car. And so when you say type of D double square bracket 1, it's type double, because that is the type of the vector we have. Here is another list. This time the 3 things in it are unnamed. Okay, we don't have names A, B, and C. So here I've got list L1, vector 1 through 8, vector with the characters A, B, C, D, vector with the numbers 5, 4, 3, 2, 1. Okay, how does this look when we print it? Okay, so when we see structure, it just says $, and there's nothing there. And when you print this, okay, when you say, hey, give me L1 square bracket 1, it comes back and you get double square bracket 1, and then single square bracket 1. The double square bracket 1 up here indicates that this output is a list, okay? Whereas back here, because it was named, it gave us $A to kind of indicate the output is a list. Here, it gives us a double square bracket, and that's how we know the output of this thing is a list. And then what is the contents of that? It is a vector. The vector has a single square bracket 1, and it's the vector 1 through 8. When you do L1 double square bracket 1, L1 double square bracket 1, it pulls out the contents of that first train car. That's a vector, and it is just a single square bracket 1 to indicate this is the first element of the vector, and it contains 1, 2, 3, 4, 5, 6, 7, 8. So single square bracket always returns a list, returns basically the train cars itself. Double square brackets give you the contents of that train car. So what happens when we do something like this? L1, single square bracket 1, single square bracket 2. We are saying this first part, L1, single square bracket 1, gives me the first train car. Now that I have the first train car, I'm asking, give me the second train. Okay? Give me the second element of this train that has one car. Well, there's no second element. So we get back basically a null, a list with null in it. Okay? Here, if I say, hey, double square bracket 1, okay? Double square bracket 1 says, okay, pull out the contents of this. So we're getting the vector here. And now that we have double square bracket 1, that's basically that integer vector 1 through 8, I can say, hey, give me the second element there. The second element in that is just 2. Basically, L1 double square bracket 1 is this, and then I'm saying, hey, give me the second element, which is going to be that number 2 there. And that's what we see. L1 double square bracket with C1 comma 2. Again, this is recursive subsetting. It's equivalent to doing this. And so we're basically taking this thing and I'm saying, hey, give me the second element. When you use double square bracket 2 on a atomic vector, it's basically like using a single square bracket, and you're going to just get the second element there. And so we get the number 2. All right, what happens if we put a list inside a list? So I put a train inside a train car. Okay, so L2 has 3 elements in it. The first L2 is a list of 3, and the first thing in L2 is list L1. Then I have the vector 10, 20, 30, and then I have the letters D, E, F, G, H, I think, or whatever letters are in there. Okay, so we can see the top level is a list of 3. Within that first train car itself is a little mini train, basically list L1, list of 3. And we've got, the vectors 1 through 8, A, B, C, D, 5, 4, 3, 2, 1. Then we have the second train car, 10, 20, 30, and the third train car with the letters D, E, F, G. Okay, how do we reference and pull out elements from this? Okay, well, when we ask L2 single square bracket 1, that's going to give me back the train car itself that contains a list of 3. All right, so remember the top L2, the top level list is a train of 3 cars, and that first train car, it contains a list of 3 in it. So here what we see is double square bracket 1. So basically this is the first train car, or basically you get back a train, and we have the first train car, and then within that we have another train. And so to indicate what's inside that, we have double square bracket 1, double square bracket 1. Basically the first train car inside the first train car. Double square bracket 1, double square bracket 2 is inside the second train car that exists inside that first train. And then, and that's the letters A, B, C, D. And then we have double square bracket 1, double square bracket 3. So again, this is the third train car inside the first train car. So again, when we say, hey, what is the structure of L2 single square bracket 1? It is at the top level, it is a list of 1, basically a big train car. And inside of that is a list of 3, a little train inside that first train car. And that's why you see it printed out double square bracket 1, double square bracket 1, double square bracket 1, double square bracket 2. Okay. If we do L2 double square bracket 1, okay, so now we're pulling out the contents of that first train car, which is just a train of 3, and that's exactly the same as list L1. List L1 is exactly this. So if we scroll back to a few slides back, list L1 is exactly this thing, and that's what we have right here. This is list L1. Okay. First train car has this vector, second train car has that, third train car has that. Double square bracket there. And so if you say, hey, structure of L2 double square bracket 1, then that is just a list of 3. Okay, so the difference between this is that here we have a list of 1, where inside that first list, we have a list of 3. That's L2 single square bracket 1. L2 double square bracket 1 just extracts out that list of 3. So always kind of pay attention because now we have all of these square brackets and you have to be able to read all of these things. Okay, so L2, remember L2 is the big train, and inside that first train car is the little mini train L1. So L2 double square bracket 1 will pull out the mini train inside that L2, and then we ask for the first train car there. So we get basically the little mini train car with the vector 1 through 8 in it. L2 double square bracket 1, single square bracket 1, single square bracket 2 is asking, okay, if you have, basically, if we get this and we say, hey, what is the second train? What is the second train car here? Which is basically what we're asking here. It says, hey, there's no second train car. Okay, so we get list null. Okay. If I do L2 double square bracket 1, double square bracket 1, we're going to say, hey, look inside the first train car in L2. You're going to find a train. And then look inside the first train car of that thing. You're going to find a vector. And we'll get this vector 1 through 8. Then I can do L2 double square bracket 1, double square bracket 1, single square bracket 2. Now we're asking, hey, what is the second element inside this vector? That's just the number 2. Okay, it's a lot. Take some time, make sure you understand the differences on this slide. And if you can get through that, then you'll have a pretty good grasp on how subsetting a list works. What happens if you use a double square bracket on an atomic vector? Basically what it will do is it kind of simplifies it. So if you have basically it works pretty much the same way, except here if you have a named vector like 1, 2, 3 and with the names A, B, C, if you use single square bracket you'll get that 1 back with the name A. If you use double square bracket, it drops the name and you just get the 1. If you use single square bracket and you give it an out of bounds index, so x is a vector of length 3, 1, 2, 3, and you say, hey, give me the 5th value. Okay, R is going to return an NA. This is kind of an interesting design choice that R made, the designers of R made, but they said if you ask for something that's out of bounds on an atomic vector, you're going to get back an NA versus an error or something like that. However, if you use double square brackets and you say, give me the 5th value, then you get an error. Okay, so it's a little bit odd, but these are just some of the things that you have to know is that in R, you can use single square brackets on an element that's out of bounds and you don't get an error, you get an NA. But if you use double square brackets and you give it ask for something that's out of bounds, so the vector is only length 3 and you ask for the 5th thing, you get an error, subscript out of bounds. So that's going to be kind of an indication of where something might have gone wrong. If you use single square bracket and you put in null, okay, or base a 0, you'll get a 0 length vector. Okay, a 0 length vector. X is an integer type vector, so you're going to get an integer vector of 0 length. That's single square bracket null. If you do double square bracket and you put in null, okay, then you'll get an error. It says attempted to select less than 1 element. Other things for out of bounds and null indices. So we have similar rules for out of bounds indices. And so let's take a look at list L1 again. So this is list L1, list of length 3. We got a vector of 8, vector of 4, A, B, C, D, and vector of length 5, 5, 4, 3, 2, 1. If you say, hey, give me an out of bounds index, okay, give me the 4th train car in this list that only has 3 things. The 4th train car, you get back a list with a null, okay? Basically, and train car with null inside. If you say L1 double square bracket 4, give me the contents of the fourth train car, then you get an error, subscript out of bounds. If you do L1 with nothing inside, or a 0, if you put a null or a 0 here, you get back an empty list, basically no train cars, like train but no cars, okay? And here we have L1 double square bracket null, you get back an error again. So similar to how it worked with an atomic vector, in that, but instead of getting an NA here, you get back a list with null in it, okay? And this is basically the equivalent of a 0 length list. Okay, and that's how subsetting a list works.